Assalamu alaikum. Dear students, today we will discuss about the hydrogen spectrum. Before going to the introduction and study of hydrogen spectrum, first of all we will discuss about what is a spectrum. What is a spectrum? Dear students, by definition, spectrum is a visual display or dispersion of light when it is passed through some scattering device. The visual display or dispersion, the visual pattern which is obtained when visible light or when light is passed through some scattering device. You can use any scattering device. The most common one is the prism. When light is passed through the prism or any other scattering device, it is scattered into different components. For example, if we have a white light, if we have wavelength of a white light and it is passed through the prism, when it is passed through the prism, after passing through the prism, it will be scattered into different wavelengths depending upon the energy and wavelength of these lights. This scattering of light will produce a visual pattern. You will observe some sort of colors on screen. This color pattern is known as the spectrum. For example, when visible light is passed through the prism, it is scattered into 7 different colors and you will observe a color pattern. You will observe a color pattern. For example, you have violet, indigo, blue, green, yellow, orange and red. These are different wavelengths which are obtained by the scattering of main wavelength, main energy, which is visible light. So this pattern which is obtained after scattering of some wavelength is known as this visual pattern. These are basically colors: violet, indigo, blue, green, yellow, orange, red. These are colors, and this pattern which is observed, it is observed due to the dispersion or distortion produced of this light or this wavelength by scattering device. This pattern which is observed is known as spectrum. So we call it as visual display or dispersion of light when it is passed through the prism or some other scattering device is known as spectrum. Dear students, there are 2 types of spectrums. There are 2 types of this visual pattern. Spectrum. There are 2 types of this pattern. One is continuous and other one is discontinuous. This discontinuous pattern is also known as the line spectrum. It is continuous spectrum, it is discontinuous spectrum. This discontinuous spectrum is also known as line spectrum or atomic spectrum. When visible light is dispersed or scattered by some scattering device, it will produce 2 types of color patterns, 2 types of displays. visual displays or dispersions. One is continuous and other one is discontinuous. The discontinuous spectrum or discontinuous visual display is further divided, or simply we can say that it is also known as the line spectrum or atomic spectrum. What is the difference between continuous and line spectrum? Dear students, in continuous spectrum, there is no sharp boundary between the colors. If we have these colors and all of them are merged into one another, if there is no specific or sharp boundary between the colors, then it will be continuous spectrum. For example, you have rainbow. In rainbow, you can easily observe that different colors are merged into one another, and you are not able to isolate or identify a specific color in a specific region because different colors are merged into one another. If the pattern is such that all the colors are merged into one another and there is no sharp boundary between the colors, then it will be continuous spectrum. Sunlight comes to the earth via continuous spectrum. The light produced by incandescent bulb, filament bulb, is also a continuous spectrum. While in discontinuous spectrum, which is also known as line spectrum, there are specific colors with specific sharp boundaries. For example, you can see here there are 7 colors, and if these colors are differentiated from one another by these specific boundaries or lines. For example, if we have violet, then we have a boundary, then indigo, then boundary, then blue, and so on. If we have a sharp boundary between different colors, then this pattern will be known as discontinuous spectrum or the line spectrum, because there are sharp lines between colors. So it is also known as the line spectrum. The spectrum observed by different atoms. The spectrum observed by different atoms according to the Bohr's atomic model are line spectrum. That's why line spectrum is also known as atomic spectrum. So in atomic spectrum, we will discuss the hydrogen spectrum. Students, what is hydrogen spectrum? Students, when an hydrogen atom is subjected, hydrogen atom is subjected to electric discharge. When an hydrogen atom is subjected to an electric discharge, there will be excitation as well as de-excitation. There will be excitation and de-excitation of electrons. This excitation and de-excitation of electron will cause emission or absorption of some sort of wavelengths, some sort of energies, and when these energies are subjected to scattering devices, they will produce a visual pattern which will be known as spectrum, and that spectrum is obtained from hydrogen atom. As we are using hydrogen atom, so it will be hydrogen spectrum. Students, actually what will happen here? According to Bohr's atomic model, according to the Bohr's atomic model, an atom consists of nucleus having specific paths around it. These paths are discontinuous paths. These paths are discontinuous paths having specific radius and energy. Similarly, from nucleus, this shell has specific radius and energy. we have another one. It also has specific radius and energy. According to the Bohr's atomic model, electrons are revolving around the nucleus in specific circular paths having definite or having fixed radius and energy. When electron jumps from one lower level to a higher energy level, then energy will be absorbed. And if electron jumps from higher level to lower level, it will emit energy. So there will be emission and absorption of energy by the shifting or jumping of electron from one level to another level. This shifting is known as transition. And transition may be of two types. Number one, excitation, and number two, de-excitation. What is excitation? Absorption of energy and jumping from lower to higher level. During excitation, electron jumps from lower to higher level. While during de-excitation, reverse will occur and electron will jump from higher energy level to lower energy level. Students, one thing that you always have to keep in mind that these circular paths which we have called as orbits, these are also known as energy levels because these are specific points, these are specific energy points around the nucleus where electrons exist as well as revolve. So orbits or shells are also known as the energy levels. And if an electron jumps from one orbit to other orbit, it means it jumps from one energy level to other energy level. And when there is a transition, jumping from one level to another level, there will be a change of energy. And where there is a change of energy, there will be associated wavelengths as well. So when electron jumps from one level to another level, there will be specific energy packets, specific energy changes. These changes have associated wavelengths. And when these wavelengths are scattered from scattering device, they will produce a visual pattern which is known as the spectrum. Students, Bohr predicted all these things, all these ideas in 1913, but there are different concepts about hydrogen spectrum. 5 different scientists have worked on it and gave their concepts. Number 1, when electron in hydrogen atom gets excited or de-excited, it will produce spectrum, and each spectrum consists of number of smaller wavelengths or smaller lines. That's why we will get some lines, and by the combination of these small lines we will get a series. There are 5 different scientists who worked on hydrogen atom. Number 1, Lyman. Then Bauman. Then we have Bastian. Then we have Brackett. And then we have Fern. These scientists gave their own concept about the revolving electron in a hydrogen atom. According to Lyman series, hydrogen has single shell. Hydrogen has single shell and electron is revolving in first orbit. According to Lyman series, hydrogen has only one shell, one energy level in which electron is revolving, and that one is of first energy level. That is first energy level. He said that hydrogen atom consists of nucleus having first energy level in which electron is revolving. This electron, when subjected to electric discharge, will be shifted or excited to higher energy level, which may be of value with N2, then N3, then N4, then N5. Let's suppose we have an hydrogen atom having 5 different energy levels, and these scientists worked on these levels. According to Lyman series, when hydrogen atom is subjected to electric discharge, hydrogen element is broken down into hydrogen atoms, and these atoms absorb that energy, that electrical energy, and gets excited. When they get excited, they may be shifted from N1 to N2. This is N1, this is N2, this is N3, this is N4, and this is N5. This electron may jump from N1 to N2, or it may jump from N1 to N3. It may jump from N1 to N4, and it may also jump from N1 to N5. There are different possibilities. Electron may jump from first energy level to second, first to third, first to fourth, first to fifth. These are possibilities for Lyman series. Similarly, Balmer gave his concept, and he said that the hydrogen atom, in hydrogen atom, electron is present in second energy level. This series belongs to this whole series. Belongs to Lyman series. According to Balmer series, electron exists in second energy level. Electron revolves around the nucleus in hydrogen atom in second energy level, and it will jump from N2 to N3, N2 to N4, N2 to N5. Similarly, Parsons said that electron is revolving in third energy level, and it will jump from N3 to N4, N3 to N5, N3 to N6, and up to so on. It may jump from N1 to infinity, N2 to infinity, and N3 to infinity. Similarly, Brackett said that electron in hydrogen atom is revolving around the nucleus in fourth energy level, and it will jump from N4 to N5, N4 to N6, N4 to N7, and N4 to infinity. That was the concept of Brackett. And according to the Fermi concept, electron is revolving around the nucleus in fifth orbit, in fifth energy level or fifth orbit. And when it gets excited, it will jump from N5 to N6, N5 to N7, N5 to N8, and N5 to N infinity. That was the concept of Fermi. Students, electrons will jump from low energy level to higher energy level. They will absorb energy, and after absorption they will be at a position with higher energy level. But an atom or a substance with higher energy level will be least stable or less stable as compared to the electron with low energy level. An electron with higher energy will be less stable as compared to an electron with lower energy. It means all of these possibilities, all of these transitions lead the electron to, or lead the atom to less stable condition. They will get stabilized by de-excitation. In de-excitation, electron will jump from any of these levels to the respective levels. For Lyman series, electron can be de-excited from any higher level to the first energy level. For Bomber series, for any higher level to the second energy level. For Paston series, electron will jump from any higher level to the third energy level. And from bracket series, electron will jump from any higher level to N4. And for Fern series, electron will be de-excited from any higher level to the fifth energy level. This is Lyman series. This one is Balmer series. This one is Paston series. This one is bracket series. And this one is Fern series. When there is a transition of electron between two levels, these 5 series will be observed. Out of these 5 series, the first two, Lyman and Balmer series, were observed before Bohr's atomic model in 1887. In 1887, Lyman and Balmer observed the transition and gave their series which were known as Balmer series and Lyman series. Why these are known as series? Because when you look at each series, it is composed of, or it consists of different lines. Look at here, when this jumps from N1 to N2, this will be first transition. So first transition will be known as alpha transition. When it jumps from N1 to N3, it will be beta transition. When it jumps from N1 to N4, it will be gamma transitions. When it jumps from N1 to N5, it will be sigma transitions or delta transitions. You can name it as alpha, beta means for Lyman series it is alpha series, it is alpha line, it is beta line, it is gamma, it is sigma lines. So you can say that and you can observe that electron can jump from N1 to any higher level, or after de-excitation from any higher level to first energy level. It means Lyman series consists of number of smaller lines. Each series is composed of number of smaller lines. That's why each pattern will be known as series. They gave the concept of Lyman and Balmer series, but they were not able to justify their concept. Bohr in 1913 explained these concepts by predicting the atomic model. Dear students, we can find energy as well as wavelength as well as wave number and frequencies of these transitions. When electron is transited from N1 to N2, there will be a specific energy change. So if there is a specific energy change, we can find associated wavelength, frequency as well as wave number, as we have calculated earlier in the radius, energy, wavelength, wave number calculations. So we have an energy change associated with each transition, and with the usage of this energy we can find the wavelength and frequency as well. So how can we find the frequency? We can find the frequency by using the equation as nu bar is equal to constant z square E4 m divided by 8 epsilon naught square h cube c. This is into 1 over n 1 square minus 1 over n 2 square. Students, all of these factors are constant. Here Z is atomic number, E is charge number, M is the mass of that atom, 8 is constant, epsilon naught is the permittivity of free space, it is also constant, H is the Planck's constant, and C is the speed of light. So all of these constants have specific value which is known as constant R, and this constant R is known as Rydberg's constant. Rydberg's constant, and it has the value of Rydberg constant R is 1.09687 into 10 raised to the power 7 per meter. This is the value of Rydberg constant. We have used this value, and now we have into 1 by n 1 square minus 1 by n 2 square. This is nu bar. It is nu bar. This is nu. It is frequency named as nu, nu, and this is nu bar. Nu bar, which is, it is frequency and it is wave number. So we can find the associated wave numbers, associated wavelengths. What is wave number? Number of waves passing through a certain area. Number of waves passing through unit area or a certain area is known as wave number. So we can find energy as well as frequency, wave number and wavelengths of these transitions. So how can we use this equation in these series one by one? We can resolve it. Dear students, N1 is the lower energy level, N2 is the higher energy level. What does N1 means? N1 means lower energy level, and N2 refers to the higher energy level. N1 is lower energy level while N2 is the higher energy level. For first of all, for Lyman series, according to the Lyman series, the lowest possible energy level through which transition can occur means from which electron can jump to higher levels, or electron can be de-excited back to the lowest possible level is, for Lyman series, N1 will be equal to 1 and N2 will be equal to 2, 3, 4, 5 up to so on infinity. Means transition can occur between first energy level and any other higher energy level. In case of Balmer series, according to the Balmer's concept, electron in hydrogen atom exists or revolves around the nucleus in lowest possible energy level N1, which is 2. It means according to the Balmer concept, there will be no first energy level. So we will have N1 is equal to 2, then N2 will be equal to 3, 4, 5 up to so on infinity. Means transition occurs between second energy level and any other higher energy level. Students, For Paschen series, n1 will be equal to 3 and n2 will be equal to 4, 5, 6 up to so on infinity. For bracket series, we have n1 as 4 and n2 is equal to 5, 6, 7 up to infinity. Then we have the Fern series. In Fern series, n1 is equal to 5 and n2 is equal to 6, 7, 8 up to so on infinity. Students, look at the values of n1 and n2. You can observe that with the change in series, each series gets shorter and shorter with respect to the harmonics. Means each series with the increasing value of n1, each series will have one laser wavelength. For example, in Lyman series, transition will be between n1 and any other higher level. In Balmer series, transition between second and any other higher level. Here n1, here the wavelength for first shell or first energy level is missing in Balmer series. In bracket series, first and second both are missing. In bracket series, first, second and third are missing. In Fern series, first 4 are missing. This contains 1 up to infinity. This contains 2 up to infinity. 1 is missing. Wavelength for first energy level is missing. Here wavelength of second energy level for Paschen series, wavelength of second and first energy levels are missing. In bracket series, the wavelengths for first, second and third levels are missing. And in the Fern series, the wavelengths for first, second, third and fourth energy levels are missing. Means it is short of 1, 2, 3, 4 energy levels. So respective energy and respective wavelengths are missing for Fern series. So with the increasing value of n, the series gets shorter and shorter with respect to the harmonics or with respect to the wavelengths. Hopefully you got this point. Now students, we are interested in finding the value of wave number. Nu bar is equal to R, red bar is constant, having the value of 1.09678 into 10 raised to the power 7 into 1 by n1 square minus 1 by n2 square. Students, by putting the values of n1 and n2, you can easily find the wave number for respective series. For Lyman series, for example, you will put n1 as 1 and n2 as 2. So it will be 1 square and 2 square. In case of, and after resolving it and multiplying with it, you will get the wave number for a specific transition. n1, n2, n1, n3, n1, n4, n1, n5, n1 and n infinity. Similarly, for Balmer series, n1 is equal to 2. So we will get 2, 3, 2, 4, 2, 5, 2, 6 to infinity. Similarly, for Paschen series, you will have n1 is equal to 3. Therefore, 3, 4, 3, 5, 3, 6, 3, 7, 3, infinity. For bracket series, n1 is 4. So you will have 4 and 5. 4, 6, 4, 7, 4, 8, 4, infinity. For Fern series, you will have n1 is equal to 5, then n2 will be equal to 6, 5, 7, 5, 8, 5, infinity. You will get number of wavelengths, number of frequencies, number of wave numbers and number of transitions in general. So you can find wave number for each transition. There is one thing which is limiting line. The concept of limiting line. What is limiting line? Limiting line is a specific wavelength. Specific wavelength, specific energy, specific wave number, specific frequency obtained when electron jumps from n1 to n infinity. What does n1 mean? n1 means lower energy level and n2 means higher energy level. For Lyman series, it will be transition from 1 to infinity. For Balmer series, it will be 2 up to infinity. For Paschen series, it will be 3 up to infinity. For bracket series, it will be 4 up to infinity. And for Fern series, it will be 5 up to infinity. So these are limiting lines for all of these series. Limiting line of Lyman series means transition between first energy level and infinity level. For Balmer series, it means transition between second and infinity level, and so on. So main point which you have to keep in mind is the associated wavelength and wave number. By studies, it is revealed that, it is observed that Lyman series is observed in UV region, in ultraviolet region. Balmer series is observed in visible region. Visible region of what? Visible region of spectrum, electromagnetic spectrum. Lyman series, all the wavelengths obtained through Lyman's concept or Lyman series are observed in UV region of, ultraviolet region of the spectrum. Balmer series is observed in visible region, while bracket, Paschen, bracket and Fern series, all of these are observed in infrared region of spectrum. These are observed in infrared region of electromagnetic spectrum. Students, there are some concepts which are related to the MCQs, and that are: number 1, Lyman series ranges in UV region, Balmer series ranges in visible region, Paschen, bracket and Fern series range in IR region. But we have discussed about limiting lines, so there is another concept that limiting line of Balmer series. The limiting line of Balmer series means transition between n2 to infinity. Transition between n2 and infinity lies in limiting line lies in UV region. the limiting line for Balmer series. All the lines obtained for Balmer series are observed in visible region, but the limiting line for Balmer series is observed in UV region. Students, this was about hydrogen spectrum. This is about hydrogen spectrum. Hopefully you got all the concepts. For any query you can ask question. Thank you so much. Allah Hafiz.